Hey, welcome. I bet you've already touched it, maybe a dozen times today, and probably never gave it a second thought. Well, we're about to dive into the invisible engineering that is, and I mean this, literally holding our modern world together. So, let me ask you something. Think about the book on your shelf, or that box of frozen pizza in your freezer, or even the trim inside your car door. What's the one thing they all have in common? What is that invisible force that's holding all of it together? Now, if you're thinking glue, you're on the right track, but we're going to have to upgrade that word. Because what we're really talking about here is an incredibly sophisticated, high-tech science. It's an entire field of engineering designed to solve some of the toughest problems out there today. So, let's pull back the curtain on the unseen engineering of glue. You're about to find out that making things stick in the 21st century is way, way more complex than you'd ever imagine. You see, modern adhesives have to survive on what is basically a brutal battlefield. We're talking about factory lines moving at lightning speed. We're talking about trying to bond really difficult surfaces like glossy coated papers and slippery plastics. These bonds have to hold up in extreme temperatures from a deep freeze at -40°C all the way up to scorching heat. And as if that's not enough, they also have to meet incredibly strict food safety laws and deal with new problems like the weird oils found in modern digital printing inks. So yeah, you can't just go buy some generic stuff off the shelf for this. It requires a really specialized field, glue engineering. The whole point of it is to create totally custom, tailor-made adhesives for these very specific, very demanding jobs. Okay, so how do these engineers actually pull it off? Well, they mainly work with two major families, two different approaches to adhesive technology. Let's break them down. So here are the two big players. On one side, you've got your water-based adhesives. In this case, water is just the delivery truck, right? It carries the sticky polymer. The bond only forms once that water either evaporates or gets soaked up. This makes it perfect for things that can absorb water, like paper and wood. Then, on the other side, you have hot melts. These are basically solid plastics that get melted down, squirted on, and bam! They form a super strong bond almost instantly as they cool down. Their superpower? Speed. Pure, incredible speed. So let's zoom in on those water-based systems. The technical term is dispersion adhesives. Just picture it. You have these tiny little particles of a sticky polymer just floating around in water. When you put it on a piece of cardboard, the paper acts like a sponge, sucking up the water. This forces all those little particles to smash together and lock into a strong, continuous film. It's elegant, it's effective, and it's usually very eco-friendly. And now for the hot melts. These are the absolute speed demons of the adhesive world. They start out as little solid pellets or blocks. They get melted down to about 160°C, and the very second they start to cool, the bond is set. It's done. Since there's no water or solvent that has to evaporate, the process is ridiculously fast, which is exactly what you need for high-speed automated production lines. So how did this all get so advanced? Well, let's look at a company that was right there in the middle of it, a company called Intercol. They started back in 1972, and the story goes they had just one small glue kettle. But they focused on making these high-quality specialized adhesives, and that little operation grew into a massive industry leader. And this is where it gets really cool. You see, hot melt isn't just one thing. It's a whole family of different chemistries, each with its own superpower. You've got your basic EVA, which is the versatile, cost-effective workhorse for everyday packaging. Then you have polyolefin, or PO. Its special trick is amazing thermal stability, which means it doesn't burn or char, so it won't clog up expensive machinery. PSAs, pressure-sensitive adhesives, are the ones that are just permanently sticky. Think about labels, tapes, things like that. And then you have the king of them all, PUR. This stuff forms an irreversible chemical bond. It's for the really tough jobs, like binding books or holding together parts in your car. Okay, so we've seen the tech. Now let's see it in action. How does all this advanced chemistry actually solve those crazy real-world manufacturing problems we talked about earlier? All right, our first case study comes from the world of food packaging, where keeping things safe and making sure quality is perfect creates a really tricky puzzle. So here's the deal. Factories use UV sensors to see the glue on a box to make sure every single one is sealed perfectly. But there's a problem. Recycled cardboard is full of optical brighteners, the same stuff in laundry detergent, and it also glows under UV light, totally confusing the sensors. Now, the easy fix would be to just add a standard UV marker to the glue, but you can't. Those markers aren't approved for food packaging. So what do? The innovation here was just brilliant. They developed a whole new kind of UV brightener that is certified as food safe. Problem solved. You get perfect quality control with absolutely zero risk to the consumer. Next up, let's look at a problem that was actually created by modern technology, a problem that threatened the very books we hold in our hands. You know, digital printing was a game changer for publishing, but it came with a hidden chemical headache. The inks used in digital printing are full of oils. Over time, those oils can slowly seep into the book's spine and act like a solvent, literally dissolving a traditional hot melt adhesive from the inside out. The result? Pages just start falling out. The solution was to bring in the big guns, that advanced PR hot melt we talked about. See, it doesn't just stick physically. It reacts with moisture in the air to form a chemical crosslink, a new, super tough material that's completely immune to those oils. It creates a bond that ensures that book is going to last a lifetime. So we've seen how these adhesives are solving the problems of today. But what about the challenges of tomorrow? Well, the next great frontier for this entire industry is, you guessed it, sustainability. I want to start with just one number. 70%. What on earth could that possibly mean in the world of high-tech adhesives? That number represents a massive breakthrough. There's a new hot melt adhesive, and 70% of it is made from renewable natural resources. And get this isn't some fancy product stuck in a lab. This is a high-performance adhesive that works on 95% of the packaging machines that are out there right now. It proves that a greener future for adhesives isn't just possible, it's already happening. And this is just one piece of a much bigger movement. We're seeing more and more adhesives made from renewable stuff, like starch. There are even vegan-approved glues to meet market demand. Water-based adhesives are being engineered, so they wash away cleanly and easily when cardboard gets recycled. And engineers are even finding ways to reduce waste by helping factories switch from laying down thick stripes of glue to using tiny, precise dots, saving a little bit of material on every single package made. So, if there's one thing to take away from all this, it's that we have to stop thinking about glue as just simple, boring stuff. It's a critical, high-tech component. It's custom chemistry, designed in a lab, optimized for million-dollar machines, and delivered just in time to keep our entire supply chain running. So I'm going to leave you with this final thought. The next time you open a package, or pick up a book, or peel a label, take a second and look closer at the seam. Are you just going to see a simple fold, or now will you see a hidden, brilliant feat of chemical engineering?